Good evening, everyone present here. So I am saying that your mic is on, so I will request please turn off your mic. Uh, so welcome to the first week of NPTEL course, that is water and wastewater treatment. So this is an online course, and I am here as a part of TA duty from the PMRF part. So instructor for this course is Professor Bhanu Prakash from IIT Roorkee, and my name is Manyatnam Prakash, and I am a PhD student at IIT Kanpur. So I am a one of, there are total 3 TA, and you you will be option, you have option to join any of the 3 TA from the given the list. You must have received a mail corresponding to the different TA. So let's continue. Hmm. So this is if we talk about my schedule, I will be meeting on every Tuesday. Timing will be same, that is 7 p.m. to 9 p.m. and we will be meeting via Google Meet, and the link which will be used is this link. This is already been shared with you, and every week you will be getting notification that you have to join, and the recording session of this lecture will be uploaded on the YouTube. So and I will also upload this link on the chat, so you can access anytime after the discussion. So coming to the first week of the lecture, which consists of 4 part.
మాగప్ప ఇంగ్లీష్ క్లాస్ ఉన్నాడు ఫ్రీగా ఓ ఫిగర్ వచ్చింది ముస్లిం ఫిగర్ దానికి లైన్ వేసుకుంటా పొద్దున్నాడు పొద్దున్నే
Excuse me, I will request you please.
సాయంత్రం పెట్టారా పట్టున్నారని చెప్పి
Mr. Bhanu Prakash, I will request you please turn off your mic.
పొద్దున్నే ఫిగర్లు చాలా బయట
I will request please turn off your mic. In case if you have any problem or any doubt, you can ask by raising your hand. So in the first week of the lecture, the four different part of section has been discussed. First is the importance of water and wastewater treatment. Uh, just let me ask everyone. So I have already given the one who has joined now. I have already given some part of instructions. So uh, uh, so I will request every one of you please to keep your mic off. If you have any kind of questions, please raise your hand and you can ask. You can raise your hand and you can ask. And so I will be starting the lecture. So the four different in the first week of the lecture the things which we are discussed on NPTEL portal was the importance of water and wastewater treatment. So a detailed thing a detailed discussion was happening, that why what is the importance and what are the different sources of water and how wastewater are produced and why it is needed to treat water and wastewater. The second thing which was discussed about the real world scenario, means how the present what is the scenario of the fresh water and the wastewater treatment system in the world, and the review of the fundamentals, many fundamentals like mole concept and many different things were discussed. And in the last portion, the complete a short discussion about the mass balance occurred. So, I am here to discuss some of the important question and concept which you will be utilizing in your upcoming assessment and your final exam. So I have collected questions from some different sources, and I have prepared the solution and everything, and I will be discussing here one by one. If you have any questions or any doubt in this in the slides, in any questions, you can raise your hand, and you can ask. So there are around 10 to 10 12 questions, and there are some concepts which I will be discussing one by one. So the coming to the first question, the first question is like, select the correct option for the statement given below. So this question is directly from your slides that has been discussed online. So the question is that germ theory state that certain disease causes by the invasion of invasion of the body by microorganisms which are too small to be seen except through a microscope. So you have to choose either this statement is true or false. So this is a very common statement that you might have read in your higher education secondary in your 10th or 12th class also. So but this statement was taken from the slide number 7 to 10. If you have gone through the slide, this has been discussed in a very brief way, that germ theory is a statement which was given in a real time, when when people were discussing about microorganism and all these things. So it states that germ theory can be stated as germ theory proposed that microorganism commonly referred as to germs or pathogen are primary cause of many disease. The theorem refers to the germ theory. This is theorem, and in general it is termed as a germ theory of the disease. So the question is like, this was a direct question. It's just asking that micro which are too small, it cannot be seen by naked eye. You have to see. It can be only seen through the microscope. So whether this is true or false, so it is uh, this statement this statement is true. So the answer for the first question will be true. This type of question you can accept in your assessment part, which you will be doing in assessment part, yeah, in final Qs, whatever that you will be doing in the future. So anyone in the group can confirm that am I audible and my sound is clear, or and slide is visual now. Please, anyone can confirm it. Anyone can
Audible,
confirm?
sir.
Hello.
Sir, audible, sir.
And slides are visible, completely visible now.
Yes, sir, visible, sir.
Okay, so if you have any kind of question, you can raise your hand. Okay, thank you for the confirmation. Now you can turn on. Thank you. Thank you for the confirmation. Again, I am saying that there might be some part which I will be missing, so you can ask by raising your hand. I will be happy to help you. So this type of question, this is a theoretical question, and this type of question you can expect in your QJ or in assessment. So coming to the just wait a minute. Coming to the second part, the second part, the second question. The question is the compound used by Dr. John Snow in lecture one of the big one is an fill in the blanks, yeah, the, agent, and you have to select the correct option. So for answering this question, you must have, you first of all, you have, what you have to do, you must have gone through your video. When you have gone through your video, you will be, you will come to know that the compound which was used by Dr. John Snow was chlorine. And why chlorine was used? Because around in 1984 in England there was a chlora endemic. So to so they this doctor has developed some, after doing some research, he comes to know that this is a kind of a, this can be disinfected with the help of some kind of disinfectant, and he used chlorine because chlorine is often used as disinfectant, and because it has a strong oxidizing properties. The why it is a strong oxidizing, why it has strong oxidizing property? Because it has a tendency to gain electrons. So the question, the this is a this is a two part question. First you have to know that which kind of chemical it was he has used. So he has used chlorine, and what is its nature? Its nature is, it is oxidizing because it has a tendency to gain electron. This was also discussed in slide number 10 of your online lectures. So the correct answer for this question will be option A, that is oxidizing agent. So I hope this is clear, and I will be moving forward with next question. So again, this question is from previous assignment, like previous year assignment. So this question was asked in previous assignment. So you can accept that such a similar type of question this year also. So make sure that before attempting or giving any cues, you have must watch all the videos. So coming to the question number 3, which is a very this is related to drinking water. The question is, select the correct statement regarding the acceptable limits for drinking water in Indian standards. So there are 4 questions, and you have to answer that which one of the following is correct. So for answering question, you have to refer to the IS code, that is 1050 2012, that is specifically for drinking water. So I will be opening that the PDF of the PDF of this uh, I will be discussing this with this PDF, that is IS code. So if you open this IS code, is this PDF visual to you? Anyone please confirm it? Hello.
Sir, visible, sir.
Okay. So you can. Okay. Thank you for the confirmation. So to answer this question, you must have the knowledge of this IS code, that is Indian Standard Code 10500 2012. This is a very general question in any interview, or for any interview. Like people generally ask, if you are if you are appearing for any environmental company or environmental place, then people may ask that what is the which IS code is used to see the specification for drinking water. Then you must be aware that it is IS 1050 2012. This you have to tell completely that IS 105500 2012. So if you will, you can download it from internet. So there is one table where they have discussed, they have given some limits, that is required limit, and there is a permissible limit. So required limit is like, suppose when you are drinking water, so there should be some requirement of that parameter, such as it should have some required pH, it should have some amount of ammonium, and this thing. And there is permissible limit. Suppose the supply, the water which you are getting is not treated, yeah, yeah, somehow contaminated, so that water should not be exceeding this permissible limit. So, and any kind of water that you are drinking below this, above this parameter, then that water is not suitable for drinking purpose. So it is said that if you are into environmental engineering, you should remember this parameter, because anyone can ask you what is the permissible limit for aluminum 0.2 milligram per liter or ppm. So I will suggest that everyone who is into environmental engineering, or everyone sitting obviously must be into environmental engineering, should remember this table, because in many interviews when I was appearing for the IIT Kanpur PhD interview, then I was asked about this fluoride. What is the permissible limit of fluoride? And it is 1 point. It must be mentioned. It is 1.5 ppm, and it must be mentioned here. F fluoride. So these are simple things which people ask. So you should have idea about this PDF, yeah, this IS code. So coming to back to our question, that the pH range is 6.5 to 8.5, and you can see that, yeah, this is acceptable, that our pH value should be 6.5 to 8.5. 8.5. So the option A is correct option. The second question is TDS should be less than or equal to 700 milligram per liter. Coming to the this total dissolved solid, here it is said that acceptable limit is 500 unit, but here it is written that acceptable limit should be equal to or less than 700 milligram per liter, or 700 ppm. So option B is incorrect option. The third is total hardness. If I am going too fast, then you can also you can ask that please stop. I will just go slow, because sometimes I hear a complaint that I am going too fast. So if you are facing some problem, you can ask me to slow down. There is no problem in that. Okay now. So the third option is total hardness. So total hardness, you can see from here, it is 200 ppm, yeah, 200 milligram per liter as CaCO3. Why it is as CaCO3, I will discuss at the end of the lecture. At the end of lecture. So the total hardness is less than or equal to 200. So option C is also correct. And coming to the fourth option, that is nitrates are less than or equal to 55 milligram per liter. So if you come here, then about nitrate, it is only 45. So option D is also incorrect. So overall, only option A and C are correct. Again, you will be facing this type of questions. Uh, whatever I am discussing here, these are general questions which you can face, which you will be facing in future, either in your interview or in this NPTEL course lecture. So you should have idea about this IS code, that is 10500 2012. So I will when I will be sharing this PPT, I will attach the PDF also, or you can directly download this from internet via searching IS 10500 2012 drinking water. So already discussed, the correct option will be A and C. So coming to the next question. So if anyone has any kind of question, you can ask. So anyone have any kind of doubt?
No, sir.
Okay, thank you. So coming to the fourth question, that is total coliforms are possible indicator of. So this is also a previous year question. The options were fecal contamination or chemical contamination. So first you should know what is this what is this total coliform. Yeah, why this question is how this question is related to our water. So what happened that in water, there might be very many kind of contaminant, biological contaminant. So we cannot measure each and every contaminant, microbial contaminant. There might be large number of contaminant, microbial contaminant. So we cannot measure each and every, that suppose, because that will be a very tedious work, and that will be very costly also, because if someone is measuring virus separately, bacteria separately, then that will be very tedious work and costly work. So what happened that there has been a method, uh, there has been a method generated, where it has been shown that if in your water sample if you have coliform bacteria, then that is a indicator, that is a indicator organism, and that will tell that your water is contaminated with microbial contaminant. Microbial contaminant, that is also microbial contaminant can be of many parts. So here we are just discussing about the fecal contaminant. So the way in which total coliform is defined as total coliform or fecal coliform are the E. coli are the indicator of drinking water parameters. Why it is a indicator? Because we cannot measure each and every bacteria. So we have to develop a method. We have to develop a method that will indicate that if this bacteria is present, then we can say that our water is contaminated. So they have developed this they have not developed because it was already there in the water, their water. So we have several techniques such as MPN method, glass plate method. From this method, we confirm the presence of this coliform bacteria. So there is certain parameter, as you can see in IS code. Again, you will go to the IS code. Suppose if the coliform bacteria is up to that limit, then your water is safe for drinking. If your bacteria is less than greater than, indicator bacteria is greater than that limit, then your water is not safe for drinking. So the total coliform bacteria is a large group of collection of different kind of coliform bacteria. Fecal coliforms are type of total coliform that mostly exist in feces, and E. coli is a subgroup of fecal coliform. So this is like some kind of scientific term which is used. The overall point of this is that this total coliform bacteria is a indicator of fecal contaminant. It does not, it just represent a is your water microbially contaminated or not. So the answer of this question will be A, that is fecal contaminant. The chemical contaminant which we check for water is very different. We measure different things like what kind of chemical contamination can be in their water. Either it will be presence of high sodium, calcium, magnesium. So their testing method is very different, and the testing method for fecal contamination is also different. That is done with the help of total coliforms. I hope this is clear for everyone. So coming to the fourth question, select the pathogen a typical sand filter can remove efficiently. The options are viruses, protozoa, worms, and bacteria. So for answering this question, you should have knowledge of what are the size ranges of these different four different pathogens. So we know, if you go through the, if you read about the sand filter, the typical pore size of a sand filter is around 20 micron to 100 micron. So anything which is larger than this size will be trapped by this sand filter, and that can be removed efficiently. So if we look at the different pore sizes of pathogens, then viruses has a sizes of 0.01 to 0.1 micron, and you can see that this pore size of sand filter is only 20 micron to 100 micron. So this virus can easily pass through our sand filter, and it won't be removed. Second is protozoa, who is its size range is between 2 to 200 micron, 200 micron. So what will happen that it can be easily trapped. So protozoa has also some of the protozoa are very small, some protozoa are very large. So the larger protozoa can be easily attached. As here we are, there is no specific that what kind of protozoa they are talking. Either it is large or big. So we will be consider that it is mostly talking in average. We will consider that as the size of protozoa is around greater than 100. So it can be easily trapped here. Talking about the worms, these are visual with our eyes, naked eyes. So there is no sizes are in centimeter, mm. So it will be easily trapped. Coming to the second, fourth option, that is bacteria. Its size ranges between 0.5 to 5 micrometer. So this will be also easily passes through the pore sizes of this sand column. So our correct option will be only these two, that is protozoa and worms, and other two can easily pass through the sand filter. Hence the correct answer for this question will be B and C, that it only protozoa and worms can be easily removed with sand filter. Anyone, if anyone have any kind of doubt, please feel free to ask. I hope till now everything is clear. So I will be moving to the next question. So if you have gone through your video, NPTEL video, these all thing has been discussed in very brief way. Yeah, in very details with these all are questions from somehow how related to this video lectures only. And you can expect, again you can expect this kind of question in your exam. So this is the second part of your lecture, that is where we were discussing about the different treatment method, how the water passes, uh, and how different kind of treatment happens. So the question is match the type of treatment and with their primary function. So there are four type of treatment and four type of functions. So you have to match it. So I will be discussing here one by one. That is preliminary treatment, so coming to the first treatment, that is preliminary treatment. So this preliminary treatment involves the physical removal of large objects and particles from wastewater such as debris, leaves and grits to protect downstream treatment of the process. So what happens that when we collect our water or wastewater from source, so it might contains these things, the a large debris means large stones, leaves, that is from the trees and all things, and the grit, a small stones. So what will happen that if we pass those water directly into our main system where the water treatment will happen, what will happen that it will destroy our thing. So what happen that we have to somehow remove those things. So what happened that we use some techniques such as a screen chamber. We use these to remove these things. And what happened that this treatment is called preliminary treatment. Here we are not here just we are removing the larger contaminants, so that our larger objects and particles, so that at downstream our other instrument, other part, yeah, other unit which is there to clean our water can work efficiently. So what will happen, the option A, the correct match for preliminary treatment will be removal of bigger size particles. So coming to the second option, that is disinfectant treatment. Disinfectant treatment is primarily aimed to killing or inactivating bacteria present in the water or wastewater to prevent the spread of waterborne disease. What happens that this disinfection is done at the end of the your treatment unit. You have removed. There are several parameters like BOD, COD. Suppose if you are treating your wastewater, then after removing all those things, what you have to do that at end of when you are supplying your water to suppose say final reservoir anywhere. So what you have to disinfect disinfect or in other word, to kill the bacteria or pathogen that is contaminating your water. So that is done with the help of several disinfectants such as chlorine. Generally chlorine is used because it is easily available, and other contaminants such as when there is advanced treatment method, ozone or UV rays are also used. So that is I'm not discussing that part again. So here we have to see the disinfectant treatment. So here you can see that it directly say that you have to kill pathogens. So the option two, the second will be matching with the function A, that is pathogen removal. So So for first one, it was matching with C. Second one was matching with the A pathogen. So coming to the third treatment, that is primary treatment. So primary treatment is a most important treatment in your treatment unit. Whatever you, if you are treating water, that is groundwater or surface water, or you are treating wastewater. So what will happen that this during this primary treatment, a major units such as BOD controller, COD controller, everything is present here only. This thing has been discussed in very detailed way in your lectures. So coming directly, I will be just saying in a brief that what is the function of primary treatment. So primary treatment involves the physical separation of suspended solids from wastewater. This helps reduce the organic load and solid content before further treatment. So what will happen that in primary treatment, if you have gone through the lecture, they have it has been discussed that it passes through the sedimentation tank and all these things, and which helps in the removal of suspended solid from the water. So if we for the primary treatment, the function of the primary treatment is to remove the suspended solid from the water. Coming to the fourth option, that is secondary treatment. Treatment that happens after primary treatment is focused on biological degradation or organic pollutants. It targets the reduction of BOD. It targets the reduction of BOD by promoting the activity of microorganisms that break down the organic matter. So this secondary treatment method only comes in act when you are treating your wastewater. So generally, what happens that when you are treating your groundwater, that is, if you have treatment method is of two type. I think everyone is sure. One is for wastewater and one is for your groundwater. So when treatment of groundwater, it is the secondary treatment is not required because that there is no organic. Why we need secondary treatment? Secondary treatment is needed to for the degradation of organic pollutants. But it is generally seen that when you collect water from this groundwater, yeah, from river, the organic also there is separate case when you are collecting from the river. But when you are collecting water from from this groundwater, what happened that the organic load is very less, so there is no need of BOD removal. So that's why it is said that for general groundwater treatment there is no need of secondary treatment. But when you are treating wastewater, that has very high organic content, so that for that case you need secondary treatment that will control your BOD. And what is BOD, it will be discussed in upcoming lectures. So if you are unaware of this biological oxygen demand, please don't worry. In the in upcoming slide, you will this. I am just giving a overview of different treatment unit. In upcoming slides, in upcoming lectures, you will be reading in details about each and every unit. So this the secondary treatment will go with the BOD, organic removal. So and the correct match will be for 1C, 2A, 3B, and 4D. So there might be some. I might have discussed or written down something new like BOD, and in upcoming slide, this disinfectant treatment. This all will be discussed in detailed way in your in upcoming lectures in either in week 4 or week 5. I'm not sure, but that will be discussed in very brief method, in a detailed way. So please don't worry. Here you have to know just basic thing. What is the function of uh, each treatment method. And suppose if you are if you are appearing for any kind of interview, any kind of short exam, so if someone is asking what is the function of treatment, what is the function of this preliminary treatment, then this answer is sufficient. So you have to miss this kind of a statement is expected from you, that you should say any deviation from this thing like may cause you any deduction of marks or anything. So I hope everyone is clear with this thing. I will be going to the question number 7. uh, Question number 7 is from your fundamental concept, where they have discussed about this mole and all these things. So this is very interesting question, and interesting means it is a first numerical question in our question discussion. The question is concentration of calcium bicarbonate is 250 milligram per liter, and you have to match column A with the respective values given in column B. Column B. You have to find concentration in ppm, equivalent concentration, concentration in ppb, and molar concentration. So I will be calculating, discussing each and every one. So coming to the first part, that is ppm. So so uh, so you should know what is first ppm. You should have knowledge of what is ppm. So ppm is generally defined as this is 1 gram per 10 की power 6 part of solution. So 10 to power 6 means it 1 gram per million part of that solution. So now this is gram per gram. This ppm, you should not remember that ppm is a unitless quantity. So 1 gram divided by 1 10 to power 1 billion gram of that solution. Now as this calcium carbonate is dissolved in water, this as you can refer it from unit also. I know everyone has idea this calcium carbonate is a salt which can be dissolved in water only. So as this is a so this is definition for water. What will happen, and we know that this density of water is 100 gram per liter. So it is 1 gram on the numerator part, and 10 to power 6 gram in the denominator part. So if we put the value, and if you put this value 10 to power, and if you what you your target is that you want to express ppm is in term of gram per liter. So what you will do that you will remove this gram with density of water. So you will be putting you will be expressing the numerator denominator part in liter. So if you after substituting value, you will find out that 1 ppm is equal to 1 milligram of 1 milligram per liter. So this is only true for water. Just remember that the 1 ppm is equal to 1 milligram per liter is only for water. So when you are doing this for air, yeah, another liquid, so what will happen that this density will change. According to that, this formula will this equation will change, that 1 ppm is maybe some uh, for some other part it will be, it won't be equal to 1 milligram per liter. Here for the convenience, for water also density is not 1000 gram per liter, but here I have considered just for simplicity. So this is universally accepted that for one, when someone is saying that it is 1 ppm, then it is then by default it is 1 milligram per liter for only for water. Just remember. So the same question, uh, I have not considered any kind of question in upcoming slide also, but same question can be asked, like suppose you have a pollutant such as concentration of any gas such as CO2, nitrogen, that is 250 milligram per liter, then you have to represent in ppm, then that will be an entirely different thing. That if I have time I will discuss it in last, but for now just remember that this expression is just only for water. So for as the concentration is 250 milligram, so it will be equal to 250. So the first one will be matching with the B, that is concentration in ppm will be 250. I hope this is clear to you. So coming to the second option, that is equivalent concentration. So definition of equivalent concentration is given as given mass divided by equivalent mass. So given mass is 250 milligram per liter, and everyone know that the molecular mass of the calcium carbonate is 100 milligram per liter, and the equivalent mass which is given the formula for equivalence mass is calculated as molecular mass, the number of electron involved in its formation. So for formation of calcium carbonate, the number of electron involved is 2. So the equivalent mass will be 100 divided by 2, that is 50 milligram, sorry, 50 gram per equivalent. Equivalent is also sometime you will see this kind of unit, that is 50 gram per equivalent. At some place you will just see 50 gram, so both are acceptable thing. Generally in most of cases you won't see this equivalent. Unit of this equivalent mass is just 50 gram. Okay, so the if we calculate the equivalent concentration, it will be 250 divided by 50, and that will be 5 milli. Why it happens milli? Because it is milligram. So this gram and gram will uh, this gram and gram will cancel each other, and the the final answer will be 5 milli equivalent per liter. So in the I have for fundamental when I will be discussing some after the question answer, I have prepared some slide where I will be discussing about this mole concept in more detailed way, where I will be discussing about this equivalent concentration and equivalent mass once again. So if you have any doubt, you can ask now, or you can ask in the upcoming slide also. I have prepared something more on this portion. So the second will be matching with the 2D. So third option was how ppb. So this is part per million. This is part per billion. So 1 ppm by default it will be 10 to the power 1000 billion. So it is 10 to the power 6. It is 10 to the power 9. So when you see, so like here it is, when I am writing ppm is equal to 1 gram per 10 to the power 6, 6 part of solution. When it will be ppv, it will be 1 gram divided by 10 to the power 9 part of solution. So it is like 1000 times more than what is ppm, the whatever the value of ppm is ppm. So so for 250 ppm, the ppb will be 25 uh, 250,000 ppb. Okay, so third will be matching with the A. The final question is molar concentration. Molar concentration is just simply given by given mass by divided by molar mass. So given mass was 250 gram per liter, and the molecular mass for calcium carbonate is 100 gram per mole. So the if we put the value, you will get 2.5 micromolar molar. So the fourth one will be matching with the C. I hope this is clear. This is clear to you. I will be going. I will be this concept. I will be discussing once. I will be discussing it once again, in more pattern way. You might seen that some first I have discussed about equivalent mass, then molarity, but in the upcoming slide I will be discussing this in more sequence way. But first I will discussing about mole and all these things. So just let me finish the questions. So again, this question was of previous year question. So similar question you can expect in upcoming Qs also. So coming to the eighth question, this is from the last portion of your class, that is mass balance. So the question is, the mass transport in advection is along the direction lateral to the fluid flow, and in the diffusion it is more apparent in the direction of the flow. You have to either say true or false. So for knowing this, for answering this, you must have knowledge of what is advection and what is this diffusion. So just let me check. Sorry. So what happened that I have taken a reference of book Surface Water Quality Modeling by a book author Chapra. This book is about water quality modeling. Actually, when you in higher study, when you will be studying about this water modeling, these two terms are very used in very in common way. So this book is a very good book of water quality modeling, where different kind of modeling is done. This is online available. You can download this PDF and you can read it. So I have taken the pictures from this thing, this book only. So coming to the definition of advection, so advection is defined as mass transport is primarily along the direction of fluid flow, not lateral to it. Advection involves the bulk movement of the fluid and substance are transport in the same direction as fluid flow. So you can, so this is a graphical representation of advection. So what happened that it is saying that involves bulk movement of fluid and the substance, bulk movement. So what happened that suppose something at t is equal to 0 and x is equal to 0, some contaminant, yeah, some kind of chemical is being added in the water. So what will happen that its concentration throughout the time and throughout the um, throughout the space will be equal. It won't be changing with time or space. But in case of diffusion, what is happened that the mass transport is driven by the concentration difference and occurs from the area of higher concentration to a area of lower concentration. So what happened that in case of diffusion, what is happening? So a example can be of dye. So when you suppose at t is equal to 0 and x is equal to 0, if you add one drop of dye, what will happen that at initial phase your the concentration of dye will be very high, but as dye will move towards with time, and it will move away from the surface, what will happen that the dye will spread. So what happened that we say that our dye has been diffused. So the basic difference is that with a space and time the concentration remains same, but in case of diffusion, what happened that this concentration keep decreasing. So the coming to the again to the question, so this was basic definition of the advection and diffection. So the coming to the question that transport is along the direction of along the lateral direction. So no, you can see from the definition is along the direction of fluid. So what will happen that suppose a stream of water is flowing in this way. So what will happen that concentration throughout the space will be equal. There is no any intervention of lateral movement. And in diffusion it more apparently in the direction flow. But and in case of this diffusion, it does not depend upon this flow. It can be you can see here that the concentration is diffusing everywhere throughout the space and with increasing time. So the above statement is false. I hope this is clear. This has been if you have any doubt you can ask, or you can refer this book, chapter number 7 or 8. This has been discussed in very in a very detailed way. So I am here to just give you an overview that how this what is the definition of this advection, what is the definition of this diffusion. Okay, so this question is this statement is false. Okay, so the coming to the uh, next question. If you have understood the definition of this advection and dispersion, you can answer this question. So first I will discuss the question and I will ask from the audience that means from you guys that what might be the correct answer. So in the given in the image below, the each graph dissipates a type of mass transport. Mass transport can be either advection or dispersion or combination of both. So choose the correct option. So graph one, what is happening that there is concentration in the second graph, and it is third graph. So and reading was taken at T1 and T2 for all three cases, and T2 is greater than T1. So what will the correct option? Anyone from the audience want to answer this question? I have discussed about the definition of this advection and diffusion. So anyone want to answer which one will be the correct option out of A, B, C, D? Anyone? Anyone want to answer this question? You can just turn on your mic and you can answer it.
Option A, sir.
Uh, Yes, option A. So can you explain how the option A is correct? You can say option A is correct
In,
answer. So can you explain how option A is correct?
in advanced process, the flow is straight direction, sir.
Hmm. Yes, you are correct. Or in more precise way, you can say that with increase in time throughout the space, the concentration is same. So first, the graph A1 will be matching with the advection. Similarly, for graph 2 and graph 3, it might be some confusing. So what happened that you can see here that in graph first I will go through the graph 3. Here you can see a little straight. It is very small, but you can say a straight, a kind of a straight. So what happening that due to advection and diffusion, what advection is trying not to change concentration, and diffusion is trying to change the concentration. But at the surface, what will happen that the concentration will remain same. So for some time, due to combination of advection plus diffusion. So what you are observing that at t is called at initial distance, the concentration is almost same, so it must be the due to the advection and diffusion. But in second graph, what you add from the starting only, the concentration is decreasing. What happened that at t equal to 0, for a little distance the concentration was up to this, but at further distance the concentration has spread more. So the option A is the correct answer. Mhm. Just let me. Huh. So to answer this question again, I have referred the same figure, that is just 1 minute. Same figure from the Chhapra book, and the option A will be correct. That is advection, diffusion, uh, and for the third graph it will be combination of advection and diffusion. So I will request everyone, miss I will be miss the question and answer discussion part is over. So if you have any kind of question you can ask. I am okay to discuss any question again. So if not, then I will be I will be moving forward, and I will be discussing some of the fundamental concepts regarding. First is this mole concept, where I will be discussing about this equivalent weight and all these things from starting. Then second part is your during this discussion of IS code, there was unit milligram per liter as CaCO3. So I will be discussing about this alkalinity and hardness in detail way. So this will be a little different from your video lecture, but it will be useful in upcoming lectures. So yeah, till now, if you have any questions, then you can ask, or I will be going to the next slide. Uh, okay, so I think this is everything is clear. Okay, no doubt. Okay, sir. Okay, so I'm going forward with the fundamental. Some of the I have prepared some of the concept, and I will be asking some of the questions. So if you please keep calculators, pen and pencil with you, I will be asking some questions based on the discussion. Till now, I there was already framed questions which I have solved. Then I have discussed, but from now onwards, these questions are my own questions, and these questions are very simple question. So what happened that it might feel it if it is okay, miss, you will be already familiar with this thing which I am going to discuss. So So pay attention. If you have any doubt, you can ask. If you might be already knowing this, so this might be a kind of revision to you. Yes. So coming to the fundamental concept, so out of fourth part, I will be just focusing on the second part, that was fundamental, third part that was discussed to you. The first thing I will be discussing is the molar mass. So molar mass is generally mass of one mole. So the next question asks the what is mole. So mole when a mole is defined as the is total when the number of molecule, a number is given, means a Avogadro number. Everyone must have been familiar with this number, that is 6.023 into 10 ki power 23 molecules. So this is Avogadro number, and this number of molecules sum up to this number of molecules is referred to 1 mole. So any substance, when you pick up any elements and any chemical or any elements, then that must have a molar mass. And that molar mass is like, it will be it has a unit of 23 gram per mole. So that represent only one thing, that this number of molecules, that is six, this Avogadro number of molecules will be equal to the 23 gram of sodium. So this is in a general way that you must have read in your 11th class in first day only, in chemistry. So here they explain in a very detailed way that how this come. But why I am discussing it right now, because what happened that you will understand why I'm discussing in the upcoming slide. So the second part is, already you have know what is, you are already familiar with molar mass. The next question is, what is the number of moles. The number of moles is defined by given weight divided by molar mass. So now what will happen that you will be given some gram of some elements, and you will be asked that how many moles is present there. So whatever you will measure it by weighing machine, yeah, someone will tell you, yeah, this is this substance weigh this much, so what how many moles are present in this substance. So you can easily calculate by this, dividing it by with the molar mass. So the molar mass. So I think hope this is clear. So based on these two equations, a simple question that is generally asked: find the number of molecules in 20 gram of calcium. So this might feel that this is very easy question. Why I am discussing? But you should remember that when I was appearing in the IIT Kanpur PhD admission, so this question was asked. Not this question. The question was different thing. That a sodium concentration was given and find the number of ions. So 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 it might feel that you should aware of this molecules, number of molecules, because many times happen that we almost forget what we have already read in class 11th or 12th. So when you will appearing for any kind of interview, means people won't asking you very tough and tough question, they will be asking some basic question. And this question, means I was not expecting that in my exam this question will be asked. Thanks to God that I was aware of this number of molecules, I was able to answer this, and all I was able to answer this. But when I was discussing with some of the, they said यार ये याद नहीं था मुझे number of molecules कितना था. So you should not forget this thing. Okay, so this is very simple question. I hope you have solved it. So molar mass of calcium is 40 gram per mole. Number of moles will be given mass uh, divided by molar mass. So it will be 0.5 mole, and already I know that 1 mole is equal to 6.023 into 10 to the power 23 molecules. So number of molecules will be, oh sorry, there is a typo mistake. It won't be here. Just 1 minute and let me correct. Hmm. So the final, you have to report your answer. See, if you have observed, I am everywhere I am writing units, like for when I am mentioning, sorry, when I am writing given weight, I am mentioning unit. When I am writing molar mass, I am mentioning unit. So this mentioning unit, you should keep a habit of when you are solving any kind of numerical, you should be you should have a habit of writing each and every unit, because what will happen that your final when, you are not writing unit, you are you will be get mixed up with your answers, or in any kind of miscalculation, and you may lose marks in your anywhere. So at this IIT Kanpur, it is like there are many professors from environment. What happens that they will just detect your marks if you are not writing units like this way. So this is not about IIT Kanpur. Everywhere if you are studying, there is this you should have a habit of writing units. So in upcoming slides, you will everywhere you will say that I'm more focusing on the unit. So sometimes what happens is a professor when doing there is a step marking. So what he will bifurcate. Suppose the 2 marks is given for your correct answer. So he will just write that 1 marks for your correct numerical value and 1 marks for uh, just actually I cannot. Someone asked that from where can I get this? Let me read what you have asked. Actually, I will be sharing this slide with the NPTEL authority. I cannot share you directly, so you can mail them to share the class notes. Right now, Miss, I'm also not aware how you will be getting this PDF. But Miss, I have been given one Google link where I will be uploading the recording session of this lecture and this PDF to one portal. So I don't know what they will be doing with it. So you have to mail to NPTEL directly for this notes. I hope this is clear. Okay. So hmm. So the final answer will be this much molecules. Once you are familiar with molar mass and number of moles, next thing which come hmm, next thing which comes is molarity. So molarity, you must have seen that when I was discussing one question, I directly write the molarity. That was fundamental question. 250 gram of calcium carbonate is there, and what will be the in that question? I have directly written molarity. So molarity is defined as number of moles divided by volume of solution. Just remember volume of solution and the number of moles. So you will be given some question like uh, x number of moles is there, find this molarity. So you will be using this formula, the number of moles divided by volume of solution. So just remember this formula is very important, because many just to mix up the things, the people sometimes they give different type of volume. There's volume of solute, volume of solvent. They will just give you in a different way, and they will ask you to calculate the molarity. The volume of the solution will be the total sum of volume of solute plus volume of solvent. So this is very misconception, yeah, you may say mistake people a student do when they are calculating molarity, that they don't they might substitute wrong value if two different value are given, that is volume of solute plus volume of solvent. So you have to, when you are writing the volume of solution, you must be aware that it is a sum of volume of solute plus volume of solvent, and number of moles will be whichever they are asking for whatever elements they are or whatever chemicals they are asking to calculate the molarity. So the unit will be mole per liter or molarity. This capital M is represented. Just remember this mole and this is capital L. Whenever you are representing liter as a unit, you will represent in capital L, not in a small l. So when you will be reading some research paper, you will always see that suppose they are writing milligram per liter. they will always write capital N, never a small l. So this is a common practice which people do at, this is very minor thing, like I may write a small l, what's the problem, but this is not scientific writing. So you should write in capital L. Similarly, when you are writing in millimolar, that is 10 to the power minus 3 molar, then you should be representing in a small n, m, capital M. So you should aware of this thing. So you might be aware. If you are aware of this, very good. Not, if you are not aware of this, you should take notes of all these things. So these two things I have already discussed. Equivalent weight, gram equivalent. Equivalent weight I already discussed. That is molar mass divided by number of electron transfer. So what does you mean by number of electron transfer? So what happened that when calcium was forming, that is Ca was going to Ca2 plus. So what happened that Ca will be releasing 2 electron, then it will be forming calcium 2 plus. So number of electron involved in formation of that ions is how much? 2. So that's why the value for the calcium was 2. The molar mass of calcium is, everyone know, that is 40 gram per gram per mole, and number of electrons will be number of, that is number of electrons involved in formation of that elements. So sometimes you will say that now valency is also written, but that is also okay, because valency of calcium is 2. But sometimes that is misleading, because sometimes what happens that when you are calculating equivalent weight, you will be calculating equivalent weight with respect to some chemical reaction. So what happened that for a single, no, actually I should not discuss this thing. Just remember, sometime you will see this valency also and number of electron transfer also. It's okay to mention, this is no problem. Then there is gram equivalent. gram equivalent Gram equivalent comes from the given weight divided by equivalent weight. The gram equivalent is defined as given weight divided by equivalent weight. And similar to the normality, there is one another term, normality. So what happens that many times when you will be reading things, the things will be discussed in normality. The normality is defined as number of gram equivalent divided by volume of sample, and its unit is equivalent per liter or normality. Again, I am discussing this because again this a question was there in the written exam, like similar, the simple question, find the molarity and normality of the given solution. So you should aware, you should miss, it is very common, but you should be aware of this thing. And there is this relationship between normality and molarity. Normality is equal to molarity into electron transfer. So this is its proof is, means I have not written down its proof, but I will discuss it here uh, orally. So I hope you please follow me, you will get how, means how this relationship comes. So the normality is defined as number of gram equivalent divided by volume of sample. Now this, keep this volume of sample separate, and you know that number of gram equivalent is given by given weight divided by equivalent weight. So what will happen that you will put this given in place of this thing, you will write given weight divided by equivalent weight. And you know that this equivalent weight, what is the definition of equivalent weight? So currently what happened here, you are in numerator it is given weight, in the denominator it is equivalent weight. Please turn off your camera, oh sorry, mic. Hello, hello. uh, if you have any question, you can just raise your mic, then you can turn on your camera. I'm sorry for asking to turn off your camera. If you have any question, you can ask. Hello. If you have any question, you can ask. Yeah, should I? move forward. Okay, no response, so I will be moving forward. So what happened that in our numerator, okay, so in our numerator, it will be in numerator it will be given weight, and in the denominator it will be equivalent weight. So on now in denominator, I will be keeping this equation, that is molar mass, and on the upside it will be number of electron transfer. So now the number of electron transfer and volume of sample will be side. So what happened that in our numerator, what things are present, that is given weight, and in the denominator it is we are having molar mass, and we know that given weight divided by molar mass is mole. I have already discussed this, that given mass divided by molar mass is number of, sorry, given mass, yeah, given weight divided by molar mass is number of moles. So what will happen that after this divided by this, it will give number of moles, and volume of sample already present is there. So number of moles divided by volume of sample will be molarity, and number of electron transfer comes from this place. So this equation is can be derived in that way, that is normality is equal to molarity into number of electron transfer. I hope this is clear. So if someone will ask you to derive this equation, you can easily derive. This is very simple equation. This is very, you have to write all these four formula. Sorry, this first formula, second formula, third formula, fourth formula, and finally this formula. There is no finally this formula, and you can substitute each other, and you will be finally getting this relationship. And you should remember this normality. The use of normality is generally done in experimental. Many experimental like COD, BOD, they generally talk in normality, that you have to prepare this normal of solution. So these two terms are very used, miss, are used in most common way in your experimental, when you will be doing your experiment in environmental engineering courses. So normality is equal to molarity into number of electron transfer. So I hope all these formula are clear to you. So based on this question, I would like you to solve these questions. So what happened that question is 71 gram of Na2SO4, which is soluble salt, is dissolved in 500 ml of water to give sodium and sulfate. Find the moles, molarity, equivalent weight, gram equivalent, and normality, sorry, of all these three. So I will be giving you, it's 8:13. I will be giving you 4 minutes, 2 to 3 minutes to solve this question. And if you have any question, you can ask, but I will request you to please solve this question. You can use calculator, and molecular weight of sodium is 23, sulfate is 96. You can calculate also 23 into 2, 46 plus, so sulfur is 32 and oxygen is 16 into, and it is there are 4 oxygen, so 16 into 4. So I will request you to please solve this, and if you have any doubt, feel free to ask. If you have take your time, solve it, and say please solve it, just give me. So, did anyone you can you don't have to need to solve for all three. You can solve from for any one of out of three. So, if anyone has solved, he or she might want to share answers. Please share. If not, just give me miss. I will be start discussing it after 8:20. I am giving you 4 more minutes. And it might also remember that during discussion it might happen that I may have said something wrong, so feel free to correct me, because I am also in I have just completed my mtech and I am in first year of my phd. So I am also I also might be forgetting something, discussing something which is wrong. So feel free to uh, uh, object me, like you are discussing wrong. Yeah, feel free to correct me. There is no harm in that. Suppose if you think that this is wrong, then just stop me there only. Okay, so what should I do? Should I keep you will solve, yes? Should I discuss this question? These are very simple question. Okay. Please, anyone respond? Should I move forward? Yeah, you need time. Okay, so I think I will be moving ahead. Means I will be discuss. I'm going to discuss the solution of this question. So, I will miss. You have to calculate this thing. Mm, all 1, 2, 3, 4, and 5 things. So the everyone is familiar with this thing that molar mass of sodium is 23, molar mass of sulfate is 96 gram per mole, and this molar mass of Na2SO4 is 142, 142, 142 gram per mole. You have solved it. So just wait, and I am discussing this answers. So the moles of the Na2 is sodium sulfate will be 71. That is the formula was given weight divided by um, given weight divided how. I think you have done something wrong. Volume volume of molarity. What is the formula of molarity? Molarity formula is mole divided by volume of the sample. Volume of the sample is 0.5 liter, and so I think you have done something wrong. Just check your answer. Miss, I will discussing. You should. That's why I said that. Please, every time you write your units, the volume is milliliter, not liter. Okay. So you must have forget. Miss, you must have written the liter in wrong way. No problem. Just see the solution. You will see what you have done wrong. Okay. So moles of this Na2SO4 is will be 7 given weight divided by molecular weight, that is 142. So it will be zero point 0.5 mole. So and it already said that when sodium sulfate dissociate, it forms sodium Na plus and sulfate 2 minus. 2 minus. And everyone is familiar that every reaction happens as per stoichiometry. So when x mole of this will dissociate, x mole of this thing will form, and x mole of sulfate will, x mole of stoichiometry of sodium is 2, then 2 mole of sodium will form and 1 mole of sulfate will form. I hope everyone is clear with this. Now correct answer, molarity will be 1. So sodium, this 1 mole, x mole. If x mole of sodium sulfate will dissociate, it will form 2 mole of sulfate. Sorry, 2 mole of sodium and 1 mole of sulfate. And so I have summarized all the inserts in one table also, so that means you can see compare each other, um, so that we can compare each other. So moles of sulfate was all sodium sulfate was already 0.5. Moles of sodium will be two times the mole of sodium sulfate, then that is 1 mole. And for sulfate again it will be 0.48. So from these moles, now what I am doing, that I am calculating the weight of each element, each species, yeah, each species. So already 71 gram of sodium sulfate was there. So for sodium, what will be the weight? The weight will be mole into its molecular mass. So remember all the what the formula of mole? Mole is given weight divided by molecular mass. So now mole and molecular mass is given. You have to calculate its given mass. Sorry, given mass. So you will be multiplying the moles into their corresponding molecular weight. So mole is 1, multiplying by 23, it will be given weight will be 23. And mole of sulfate is zero point 0.5, and the molecular mass is 96, so the weight will be 48 gram. Just remember, I have everywhere I have written unit. For mole it is a small n, for weight it is a small g. Now you know the formula of molarity also. Molarity is defined as given molarity defined number of moles divided by volume of the sample. Volume of sample is how much? 500 milliliter. Means how much liter? 500 milliliter is equal to zero point 0.5 liter. So it will be moles. Zero point 0.5 moles is there, and zero point 0.5 volume is also there. So it will be 1 mole of sodium sulfate. Again for sodium, the number of mole is 1, volume is same for all solution. Volume of for all species, the volume of this solution is same, that is zero point 0.5. So it will be 2. Again for sulfate, the volume mole is zero point 0.5, and the volume of the solution is zero point 0.5. So again it will be the same. So the next question is equivalent weight. So again I am going back and discussing what is the equivalent weight formula. Sorry, equivalent weight is given by molar mass divided by number of electron transfer, or simple way valency. So for this sodium, the valency will be 1. For sulfate, the valency will be 2. And for formation of this, how much electron was involved? See, when I am discussing about this individual element, I am saying number of valency. But when I am talking about any kind of salt, I am talking number of electron involved. So for formation of this sodium sulfate, what will happen, that it will it will accept 2 electron, and it will miss 2 electron from here and 2 electron from here will be means total number of electron involved in formation of sodium sulfate will be 2. So the for the calculation of equivalent weight, what will we what we will doing, the molar mass of each divided by number of electron, या valency. So for this sodium sulfate, how much electron bar involved in its formation? 2 electron bar involved. So equivalent weight will be 142 divided by 2, that will be 71. For sodium, how much? Again, the equivalent weight, sorry, molar mass divided by its divided by what do we call, number of electron, yeah, valency, that is 1, then that will be 23. And again for sulfate, the molecular mass is 42, and the number of electron involved, yeah, valency is 2. So that's why 96 divided by 2, it is 48. The fifth one is fourth one is to calculate the gram equivalent. What is how gram equivalent is defined? Gram, again I will go into this slide. Gram equivalent is given weight divided by equivalent weight. So now you have already calculated the weight, that is 71 gram, 23 gram, 48 gram. The gram equivalent weight, you have already aware of the equivalent weight. So what will happen? It will be gram equivalent will be 1, this divided by this 171 divided by 71 1, for 26 divided by 26 1, 48 divided by 48 1. And last, normality, how normality was calculated? Normality was given as number of gram equivalent divided by volume of sample. Gram equivalent you are aware. So for calculating equivalent you have two options. Either you can use use this formula, that molarity into number of electron, or you can use the formula, um, for calculating normality. I have given you two formula na. Number of normality is molarity into number of electron transfer, or gram equivalent into volume of the sample. Suppose in this question in this question I have to calculate each and everything. That's why I have tabulated this thing, normality. Normality can be calculated by use of this gram equivalent also, or I can directly use this molarity value to calculate the normality value. So so molarity is 1 and the number of electron involved is 2. So what will be the normality? It will be 2. Again molarity is 2, valency is 1. So 2 into 1, 1. Sorry, 2 into 1, 2. And again for molarity, here it is 1, number of electron involved 2, yeah, valency 2. So the normality will be 2. Or you can use the second formula, that is gram equivalent divided by its volume of the solution. So 1 divided by 0.5 2, 1 divided by 0.5 2, 1 divided by 0.2. So a interesting thing can be observed, that gram equivalent or normality for this reaction for all species, this component and this species is similar. That is 1 1 1 for all these thing, 2 2 2 2 for all these things. So a statement is made that for any reaction for formation of 1 gram equivalent, for a one in reactant side and product side, the gram equivalent of each and every species will be equal if it has reacted completely or dissociated completely. I hope you are getting this. Is very interesting point, miss, like what is the significance of this gram equivalent, why we are calculating gram equivalent. So you can take any reaction that you know, just write in this way and just make sure that this that has completely dissociated, or that 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 uh, just 1 minute. uh, that is completely dissociated or is in equilibrium. You will see that gram equivalent is always same. So a plus b is reacting to giving c plus d, then gram equivalent of a will be equal to gram equivalent of b, gram equivalent of b will be is equal to gram equivalent of a b c d will be equal. Just make sure that is the only condition is that it is in equilibrium or completely dissociated. Okay. So a question can be arise. Suppose you have given some unknown equation, and only one thing miss, what what we will they say that a plus b is giving c plus d. The molecular mass of ABCD will be given to you. That is this molecular mass is given, and it will be given that the weight of D is suppose this much. So find the weight of ABCD. You ABC. You can easily calculate it. There is no need to do much calculation. You know only one concept you have to know, that gram equivalent of each thing is equal. So from the given weight, from the molar mass, from the number of valency, you can calculate the gram equivalent of D which was given, and you know that gram equivalent of each and every one will be same, and you know molecular mass of ABCD will be given to you. You can calculate easily. So this is significant of gram equivalent. That 1 gram of equivalent react to give 1 gram equivalent at product side. Means 1 gram react to give 1 gram. 1 gram equivalent reacts to give 1 gram equivalent. I hope this is clear, Miss. I have given some more. I have given, I have discussed this specifically just to make this point that this gram equivalent is same for any kind of reaction. So I have hope you keep it this thing in mind, and if you are appearing in gate or obviously I suggest that you should appear in gate, and there a question, I think a way back this kind of question was asked, I'm not sure, but this kind of question was asked that something is reacting, this much is forming, so how much miss find the concentration of this unknown element. Okay, so I hope this is clear. So after this thing I will be discussing another thing. Till now if you have any question you can ask, or I will just move forward. Just let me make this more. Hmm. So coming to the second concept, is alkalinity. So when I was discussing about this thing, alkalinity, is code, I was discussing about this alkalinity and hardness. This thing you will be studying in upcoming slide, upcoming lectures also, but I am still discussing this thing because to make you something, to make you understand something. So alkalinity is simply defined as ability of certain species to neutralize H plus in the water. What are those certain species? Those certain species are generally OH minus, carbonate, and bicarbonate. So that if OH minus is neutralizing your H plus in water, then it will be caustic alkalinity. If carbonate is neutralizing your water, then it will be carbonate alkalinity, and if bicarbonate is neutralizing your water, then it will be bicarbonate alkalinity. But most simple, if someone asks you what is alkalinity, you will say that ability to of certain species to neutralize H plus. After that they might ask you which kind of a species, but this is a fundamental, yeah, this is universal, you may say a kind of universal definition, that everyone define alkalinity in this way. This H plus plus will be in subscript, superscript, sorry. So it is wrongly typed. So no problem. So moving forward, see this alkalinity is represented in milligram per liter. Why it is represented in milligram per liter? Because there is two term, alkalinity and hardness. So once I will discuss about hardness also. Once these two are discussed, you will you can relate why, miss why the answer is that we have to compare alkalinity and hardness, both things together run simultaneously. Suppose any water will have some kind of alkalinity, then it must has some kind of alkalinity, then it must be having some kind of hardness. So to compare both things, that alkalinity and hardness, we represent it is in milligram per liter as CaCO3. So how this how anything is converted into CaCO3, I will just explain in the upcoming slide. So I hope if someone asks why it is represented in CaCO3, you will just answer just to compare uh, alkalinity and hardness, we represent it in milligram per liter. This is first reason. Second reason is that the molecular mass of calcium carbonate is 100. So for any calculation, it is easily used. Miss, you don't have to miss. Suppose if you are using some other element, suppose say sodium chloride, it has molecular mass of 23 plus 35.5, 58.5. So and 58.5, anything multiplying by 58.5 will give you some random number. But when you are multiplying with 100, molecular mass is 100, equivalent weight, how much, how much will be the equivalent weight, as two number of electron involved, so 100 divided by 2, that is 50. So just to for ease of calculation, we also represent alkalinity in milligram per liter as CaCO3. So experimentally, there are two methods of determining alkalinity. Alkalinity can be either alkalinity can be either experimentally measured with by titrating with the help of 0.01 normal HCl or 0.02 H2SO4, and the indicator used is phenolphthalein and methyl orange indicator. This is experimentally. So what will happen that there is two kind of indicator. You will take one sample. So you will take some certain amount of sample. First, you will add phenolphthalein indicator. If its pH is greater than 8.3, so what will happen that your solution will get turn into pink. So now you will start adding acid. As soon as you will add acid, what will happen that this acid is providing H plus, and the present alkalinity will neutralize H plus. So what will happen that pH will start sorry sorry as you are what happened that your pH is greater than 8 point, sorry, I said something wrong. So what will happen that your pH is currently 8.3. Now you are adding acid. So what will happen? pH will start decreasing. Okay. So as soon as pH will start decreasing, so what will happen that after 8.3, your pink solution will turn colorless. Means you have reached uh, a end point. So you will measure that how much volume has been consumed, and you know the normality of this HCl. So one concept is that are you aware of N1 V1 is equal to N2 V2? Means what happened that for any reaction, what happened that N1 V1 normality into volume. Normality into volume. What is normality into volume? Gram equivalent. I said now for any reaction, gram equivalent is same. So N1 into V1 will be equal to what for my solution. For my I know the normality of my acid and how much volume has been consumed to reach from certain pH to this colorless point, and we have to find the unknown alkalinity and unknown alkalinity of my sample. My sample has suppose X normal of alkalinity, and I will be knowing the volume of the my sample, that is 10 ml or 100 ml. So I will be N1 that is the zero point 0.0 normal. Suppose volume to reach from this point to 8.3, suppose 5 ml. So this one into 5 is equal to alkalinity that we have to find, and into this volume of the sample, that will be 100 ml. So from there I can find the gram equivalent of my uh, whatever miss alkalinity. So that till now I have not converted into milligram per liter, milligram per liter as CSO3. You have just calculated its normality. Once you have calculated normality, you can convert into in milligram per liter as CSO3. Similarly, what will happen that once it is reached 8.3, so now once it is colorless, so now I will add this methyl orange indicator. So as soon as you will add methyl orange indicator, as your pH is above 8.3, sorry 4.5, so your solution will turn yellow. Now again you will start adding this HCl, and at pH 4.5 you will see orange color. At this orange color. So miss at this point you have done all the titration. So volume, whatever volume consumed, you can apply N1 V1, and from that you can calculate the alkalinity. So this is experimentally. Miss, if you are in civil engineering, of course, I hope everyone here present here is in civil engineering department. So you will be doing this experiment, and it might happen that you have already done this alkalinity. Then there is one direct formula is total alkalinity is minus H plus. You suppose you have given some samples, you measure H plus, OH minus, carbonate, bicarbonate, and you put the value, and you remember that you have to add gram equivalent per liter, not in, you cannot add you can add miss gram equivalent per liter, and then you can report answer. There is one more direct formula which is generally used in your competitive examination, or miss everywhere generally people use this equation. I know that my alkalinity will be either due to OH plus or HCO3 minus or carbonate. So what happened that given mass divided by equivalent weight, what I have calculated, number of gram equivalent. I have calculated this. What is this? Is gram equivalent, and I know that I have to represent in CSO3 to compare with hardness. So now you are having and there was one statement now that for any Gram equivalent is same for everyone. Means if you want to convert one thing to another thing, then you can just multiply by gram equivalent of the element for which you want to represent your concentration. So the gram, so I want to miss, you have done miss some by some method, you have measured your OH minus concentration. Once OH minus concentration is measured, you have, this is gram per liter given weight, that is divided by equivalent of weight of OH minus, that will be around 7, that will be 17 into equivalent weight of COC3. So this will give you this equivalent weight will cut out, and your final answer will be in alkalinity in milligram per liter as CaCO3. Similarly, for SCO3, you will measure somehow, you will convert into gram equivalent, then you will multiply with gram weight to represent your answer in milligram per liter CaCO3. See, this thing is connected with the 4 5 formula that I have discussed earlier. Similarly, for this carbonate, same concept, same same concept. So once you know the concentration of all these three ions, you can report your alkalinity. This question is generally asked in this question was not asked in Viva, but when I was doing the experiment here in my exam, this type of question was asked, and in your NPTEL course also this kind of question will be asked. Coming to the hardness, presence of multivalent cations in water, most notably calcium and magnesium. So any kind of in water happen that calcium and magnesium concentration is very high, around calcium is around 50 60 and magnesium is around 10 milligram per liter. So presence of multivalent cations, any element that has valency of 2 or greater than 2, that will contribute to hardness. For example, iron 2 plus, iron 3 plus, aluminum 2 plus, aluminum 3 plus, any calcium is there, magnesium is there, concentration of these two are very high. All other elements which I mentioned, that is the iron and aluminum, are very less, that's why I am not written. But suppose you have got any questions where you have to miss, you have to tick marks that hardness can be due to which elements, and there is option of iron 2 plus, iron 3 plus, then you have to marks that also. Will sodium give hardness? No, sodium won't give any kind of hardness, because that is not multivalent cation. Okay. So type of hardness can be carbonate hardness or non-carbonate hardness. Now you may raise a question that you are discussing that it is due to calcium and magnesium, but you are discussing type of hardness is carbonate and bicarbonate, non-carbonate. So what happens that if suppose if calcium is uh, many kind of salt can be present in your water. Magnesium, calcium can be with carbonate also. Calcium can be with the sulfate also. So when calcium is with carbonate, that is calcium carbonate, then I will be saying that calcium is giving carbonate hardness. But when this carbonate is substitute, say calcium chloride, yeah, calcium sulfate, then I will be saying that it is non-carbonate hardness or permanent hardness. So difference between temporary hardness and permanent hardness is that temporary hardness, suppose your hardness is due to calcium carbonate, yeah, magnesium carbonate, then just by boiling you can remove the hardness of water. In you might have heard that people boil their water before drinking a bathing purpose. So why the miss generally they in village side, yeah, in mountain side, they just do it to remove this temporary hardness. Because by boiling, what will happen that this calcium and carbonate will precipitate out, and you will get soft water that is not hard. And non-carbonate hardness cannot be removed easily, that's why it is called permanent hardness. Suppose calcium sulfate is present, yeah, magnesium sulfate is present, magnesium chloride is present, then that won't go easily. You need some kind of mechanism to remove this. Just by boiling it won't go away, that's why it is called permanent hardness. So experimentally again, you must have done this, yeah, yeah, you will be doing in the upcoming semester, yeah, whenever you do. Hardness can be experimentally determined with the help of EDTA indicator in presence of EDTA reagent, EDTA ethyl ditetraamine acid. Just check it. What is the full form of EDTA? Okay, now, and EBT is a indicator which is initially blue in color. Its name is Erichrome black tea, but it's not black. It's blue color. Okay. So what happened that you will take your sample, you will add indicator, EBT indicator. So what will happen that it has blue color. It will it will make a complex with magnesium, whatever multivalent cation present in your system, and your solution will turn into red color. And now you will start adding EDTA. So now this M2 plus has two choices, either to make complex with EBT or EDTA. So if you have gone through complexation, hello. Sorry, there was some net problem. Yes. Hello, am I audible? Actually, there was some net issue. That's why I disconnected.
Sir, audible, sir, audible, sir. Now
Sorry,
audible, sir.
sorry for the inconvenience.
Okay.
I will restart. Uh, I hope you are able to see my screen.
Yes, sir.
Just tell me what from where did you miss what I was discussing? Can you just say so that I because I have just 10 minutes now and I have to cover this thing. What was the last thing which I was discussing?
Temporary, temporary ordinance and permanent ordinance, sir.
Oh, okay, okay, okay. So I hope. Oh, thank you for the. So So this temporary hardness can be removed just by boiling, but permanent hardness cannot be removed by simply boiling. You need some advanced technique to remove permanent hardness. Experimentally, experimentally you can find hardness with the help of EDTA and in presence of EBT indicator. So what happen that when you take your sample, you add EBT, what will happen that this will form red color solution, red complexation, and your solution will turn red. But as soon as you add EDTA, what will happen that this metal have more tendency to form complex with EDTA than EBT. So all the sorry, it will be here M. It will be M here. So what will happen that all the M which was initially making complex with your indicator will make a complex with EDTA, and your solution which was initially red in color will turn blue due to EBT, because EBT is now not reacting with anything. So you will be left out with all the multivalent cations has reacted with EDTA reagent, and you will be left out with EDTA in your solution. And what will happen that at the titration end point is indicated when the multivalent cation form complexes with EDTA, causing the EBT to revert its original blue color. So this will be your end point, and again with the help of N1 V1 is equal to N2 V2, you can calculate this hardness. Actually in this case N1 V1 is equal to N2 V2 is not used. There is some separate method, uh, the miss logic behind calculate to find the hardness is same, but here something discussed. But this is the main concept. If someone is asking you how experimentally it is calculated, you can say this is the method, but the main calculation part I cannot discuss because it takes some time. So I'm just giving you some idea. Okay, how this is conduct, how this is hardness is experimentally find out. So there is one again direct formula. Suppose with some instrument you have measured calcium and magnesium and other cations, multivalent cations. Again, given weight divided by equivalent weight give you equivalent number, and that will be multiplying with equivalent weight of calcium carbonate. You will be getting hardness in terms of magnesium milligram per liter as CaCO3. I hope this is clear. This formula is clear. The formula for both alkalinity and hardness is same. Hardness is same. Now the question is alkalinity versus hardness. I said no, that you have to compare both, so you should remember that this alkalinity is due to bicarbonate, carbonate or OH minus. Generally OH minus is concentration miss pH of your water will be around 7, so you can imagine that POH will be also 7, so OH concentration will be very less. Whatever will the majority of ions will be biocarbonate, carbonate only, and some amount of carbonate. So and hardness is also due to carbonate. Hardness is due to multivalent cation when it is associated with carbonate and bicarbonate. So there is we have to know how this we have to compare it. So what happened that this now you know that this carbonate carbon by this formula you have calculated total hardness, but you know that there is two type of hardness: carbonate hardness or bicarbonate hardness. So now how will you calculate carbonate hardness separately? So you know that this alkalinity will be due to carbonate only, which minus is neglected, and alkalinity will be due to carbonate only, and hardness can be due to both. Hardness can be due to both carbonate and bicarbonate also. So you know the value of total hardness and you know the value of alkalinity. So minimum of, and this carbon hardness can be of both carbonate and non carbonate. So minimum of these two will be your carbonate hardness. I hope you are getting what I am saying. This is very critical. Like many people confuse why it is minimum, because alkalinity is due to carbonate only, and hardness is due to both. So the minimum of these two will give your the minimum of these two will give you carbonate hardness. And remember the unit should be milligram per liter as CaCO3. I forget to mention, but unit should be milligram per liter. Similarly, non-carbonate hardness will be equal to total hardness minus carbonate hardness. So you, what will happen? Suppose now imagine that your total hardness is 200, alkalinity is 100. So what will happen? Carbonate hardness will be your 100, and non-carbonate hardness will be 200 minus 100, that is 100 milligram per liter as CaCO3. Or in second case your total hardness is around 100 and alkalinity is 200. So means alkalinity is high, means concentration of sodium, concentration of calcium, magnesium is very less, that is combining with carbonate. So that's why this hardness is less, and your alkalinity is combination, alkalinity is due to carbonate only. So the carbonate hardness will be again, suppose this is 100 200, then it will be 100, and non-carbonate will be 0, that is total hardness minus carbonate hardness. Total 100 minus 100, it will be 0. Please miss, I hope you have understood it. I'm trying my best to make you understood. Huh. So last question of the day. I request you to take a screenshot. I don't know whether this PDF will be shared with you, this PPT will be shared with you or not. But time is only 5 minutes, so I cannot discuss in detail. But this is very interesting question. Interesting in the sense like this is everywhere it is asked. Miss, if you are preparing for gate examination, this is asked. If you are miss in your normal exam also, this thing will be asked. So I request you to take a screenshot of this question and try to solve this question. I'm directly going to the solution part because only 5 minutes is left. So the question is simple. The analysis was done and this thing was found. So you have to calculate alkalinity, total hardness, carbonate hardness, bicarbonate hardness in milligram per sorry bicarbonate and non-carbonate. There will be a printing typing typo mistake. It will be non non-carbonate hardness. I think non-carbonate hardness. Sorry for the typo mistake. If you have taken a screenshot, take it, retake the screenshot, and make sure that you have correct answer. Huh. So the question is very simple. So what happened that these parameters are measured with this pH is measured with pH meter, TDS is measured with TDS machine, calcium, magnesium, this chloride, aluminum, sodium is measured with either you there is probe, but there is advanced instrument like ion chromatography, ICP-MS. You can directly measure, but somehow someone did some experiment and find these results. So you have to collect and finally you have to answer that whether this water is suitable for drinking or not. So I will be going very fastly. I will request if you can take a screenshot, please take it. So as I was, we all know that alkalinity is due to carbonate, bicarbonate, and OH minus. As pH is 7.8, so pH will be 6.2. The concentration of OH will be very less. So as compared to these two ions, because the concentration you can see one is 183. No, it's not minus 183. It's 183, and it is 15 milligram per liter. Okay, na. Hmm. So I can neglect the concentration of OH minus, and I know the alkalinity formula is given by this equation, equivalent weight of each and every one I know. So I will be putting the value, and I will be getting the alkalinity as 175 milligram per liter as CaCO3. Okay. Similarly, total hardness. Just remember, a simple question can be asked. Out of these ions, which one will give alkalinity? So hardness. So just remember only multivalent: calcium, magnesium, and this aluminum. Sodium and chloride. This data is not used in this question. This data is used in second part. That is whether suitable for drinking or not. But if someone is asking you which one will be giving hardness, only these three will be giving hardness. Okay, so I have written that only here. Total hardness will be due to total hardness formula of this and hardness will be due to calcium, magnesium, and aluminum. So equivalent weight of all these things are given. I will be putting this value, and the total hardness will be 226 milligram per liter. And again, the question was, I know that carbonate hardness is given by minimum of total alkalinity divided by minimum of total hardness and alkalinity. So non-carbonate hardness will be total minus this. So carbonate hardness is 175. Non-carbonate hardness is 226 minus 175. That is 51 milligram per liter. So the final is so this is the first part, like alkalinity, carbonate, bicarbonate, and total. I hope this is clear. Very simple. I have given too much time on the previous section, so that's why I'm skipping this. Second question was to check whether the water is suitable for drinking. You have to go through this IS code and you have to match each and every parameter. See, alkalinity and so you have to compare all these things. That is 170 is total hardness and total hardness, alkalinity, and what are else are there? pH, pH, calcium concent. You can just take a screenshot. You can compare it later. Remember, this is 183, not minus 183. And when you will compare, and then you will find that as per specification water is suitable for drinking. So what from wherever this water has been collected, it is suitable for drinking. Anyone can drink it. So with this, I in today's session, if you have any doubt, you can. So I was saying that I can share one thing that you can find this lecture on this. If you want to see the re-recording of this session, you will finding out in this YouTube channel. But sorry, I can't share. Miss, I don't have authority actually to share this um, PPT. I'm just stop presenting. In chat, I have shared you the YouTube. It will be uploaded maybe by 1 or 2 hours. After 2 hours, because it is very big file, 2 hour file. So you can copy this YouTube channel. This is my Maniratnam. My name is Maniratnam Prakash. And if you have doubt, I actually for doubt session, direct you have to directly mail to the NPTL team only. So they will forward me. Then I will be solving your question or solving your doubt. So I hope you have liked your session, like my session. If I will try miss. On next Tuesday, I will be meeting on the same time. You have to use same link, and um, we will discuss. The pattern will be the same, similar. That I will be discussing some questions, previous year questions, and then after that some concepts. Uh, that's all for today. So you may leave the meeting. I'm closing this meeting. Okay. Good night, everyone. If anyone has any kind of question, you can ask or you can please leave.